Hey guys, you're on Level Maths. This is revision, this is new syllabus for 2020-2022, and we're going to consider binomial expansion. Using Pascal's triangles, we try to undertake exam-style questions from Edexcel. Alright, if you're ready, don't forget to actually remember what we're doing before, and this is a quick footnotes that you can use for you guys. Sorry, not footnotes, but actually notes. And if I covered that in the previous video where I explained how Pascal triangle works and actually how we can generalize the rule using the sigma notation, I'll also show you how to build out Pascal's triangle. So that's a quick recap. And we consider it like simple example, x plus y to the power 4. However, exam style questions a bit more tricky. So it's right time to have a look. That's the first one, so pause the video, try to do by your own. I just used the sketch of the triangle, Pascal's triangle, and here you have the chance again to build this up. Okay, so now let's get to explanation. We need to use binomial expansion to expand and simplify 2x minus 3y to the power 5. Before we're doing that, of course, we need to get the target level on those triangle because we need to understand to which extent we need to calculate those coefficients. But before, we also need to rearrange binomial because remember, binomial, classical binomial is an addition a and b to the power 5. So as I told you, we can actually rearrange those expressions as 2x and plus negative 3y, and so that 2x becomes a and thus negative 3y becomes actually b. In this case, you'll get a classical binomial. Okay, let's try to build up a Pascal triangle and let's set up the target level. So this n equals 0, 1, 2, 3, 4, and 5. So this is our target level. So we need to reach the 5th level right there. Okay, and now we just arrange a triangle to that level. Okay, so here as well, all ones, and then we quickly can set up triangle and fill it with numbers. Okay, and 1 and 4, finally 5, 10, 10, and again 5. So now I just use that level and those coefficients, and the red blocks are actually those which are we going to use soon. Okay, we need to make full expansion. In this case, it's highly recommended to use Pascal's triangle because it works pretty fast. So actually you waste less than like 30 seconds to get those coefficients. And right now, let's just try to arrange those expansion. Okay, so we've got 2x plus negative 3y to the power 5. It will work like the following. So I just raise those a and b. We don't need them right now, just that was shown in case why it also works. Okay, and let's arrange. So the first leading coefficient is 1, so that's why we get 2x to the power 5. Okay, then goes coefficient 5, so that's why we add 5, and then 2x will get the power 4. We'll get a power 4 while, so we'll get the power 4 while the coefficient, while the second term, negative 3y, will get the power 1. Okay, so next goes 10, so that's why I will add 10 times, and 2x will get a power 3, while negative 3y will get the power 2. Then we're still adding, and there goes another 10. Another 10 with the first leading term 2x to the power of 2, and negative 3y will rise that power by 1, so that's why it's 3 now. And the pre-last, so it's going to be 5 times 2x and times negative 3y to the power of 4, okay? And the last term is going to be just negative 3y to the power of 5. Okay, now it's right time to simplify that. So that's why I just continue doing and simplifying. We raised to the power of 5, and we raised each factor inside, so 2 and x. So that's why we'll get to the power of 5 is 32 x to the power of 5. Okay, next 5 and 2x4, so we'll get 2 to the power of 4. It's going to be 16, so that's why we'll get 5 times 16, and then we have negative 3. So in total, we'll get negative 240 times x to the power of 4 and y. Just make sure you remember that when you have the even power, negative base in even power will always be positive. So that's why here we'll get 2 cube is 8, so 80, and times 3 squared is 9. So it's going to be 720, okay? I'm pretty sure that we'll get this number. And x will be in power 3 and y squared, okay? So next term, I'll just simply be calculating. So we are here now. And that's going to be negative 1080. So 1080 x squared and y cubed. So we add up the next term. Here it's going to be 810 xy to the power 4. And the last term will be negative 243 and y to the power 5. So we complete the full expansion, and that's the final form. So that's the answer, and this is expanded form. As you understand, in case of negative second term, negative 3y, we'll have actually the sequence of change in signs. So it depends on the power, and that power makes sign vary, okay? So let's go to the next one. We have Pascal's triangle to use, and we need to find the coefficient of the term x5 in the binomial expansion. So be careful here. We need to determine the coefficient before x5 term if you have the following structure. So you've got, I just rewrite for clearness, so x squared plus, so this is the fraction 3 over x. Unfortunately, I don't have a proper, math tool for that app, so that's why I'm using the incline slash. So that's 3 over x actually to the power of 7, okay? So pause the video, try to do by your own, and I'll try to explain. So in this case, I'll hire my tool, so Pascal's triangle, and the target level is the level 7, okay? So that's the target level. 0, 1, 2, 3, 4, 5, 6, and 7. So that's our target level. Okay, let's try to figure out which coefficient we need for that. Okay, so for this reason, because we have level 7, we need to get x to the power 5. Before we're doing that, we need to analyze, because I'm not going to complete the full expansions, so it's senseless in this case. So that's why you pretend that, just remember sigma notation. So in sigma notation, you'll have some coefficient, which is actually r, and choose r. And here we will have, so a, which in our case is x squared, it will get the power n minus r, and 3 over x, that's the second term, we'll get the power just r. In our case, n equals to 7, so that's why everywhere we can plug 7, but we're interested in so that the resultant of this operation, so we multiply and square to the power, actually 7 minus r, x squared to the power 7 minus r, times 3 over x to the power r, which is, in this case, we don't know r, and that the result of that should give us some coefficient, we don't know, but times x to the power 5. So we can complete the equation for powers. So let's have a look at the powers. We've got the power 2 times 7 minus r. That's the power for x. But because we divide by x, we actually use the power r with negative sign, as if we using the formula x, let's say 1 over x to the power r is going to be the same as x to the negative r. So that's why we still multiplying, in this case we subtracting using the multiplication rule for basis. So basically, sorry, not multiplication, okay, in this case it's multiplication, yeah, because we times x to the power negative r, so we'll get negative r. We complete just the powers, okay? We complete the equation for powers, and that will be equal to the power 5, okay? So make sure you understand. I just grab the powers and complete the equation using only powers, because x basis will be the same on the left side and on the right side, okay? We don't touch even 3. We care about only x. So in this case, we'll get 14 minus 2r minus r will be equal to 5. Right now, we're just trying to determine which block, which coefficient in row 7. I just highlight the target row 7. It's right there. So we're going to use this, only this coefficient in row 7. Okay. But we don't know which one. Okay. So that's why we're trying to determine the r, index r for that. Okay, so 14 minus 5 is going to be 9, and that's going to be 3r, so that's why our target is going to be 3. So well done, we determined that's a third element, but as you remember, in the formula, r starts from 0, right? So that's why up to n. So that's why we count like 0, 1, 2, and 3. So obviously we will get this coefficient. If you are not sure, you can use an alternative way to check it using 7 choose 3. Let's just recheck it and calculate the coefficient itself. So what we can do, we can complete the formula. 7 factorial over r 3 factorial and times, okay, 7 minus 3 is 4, so 4 factorial. For those who want to check using C, coefficient of combinations, let's try to calculate. So where is the n factorial here? Yes, I've got it. So 7 factorial over 3 factorial. Of course, you can cancel them, but I'm not going to do that. Yes, and we've got 35. So that works perfectly and prove that we are on the right coefficient. Okay, so that's why if r equals 3, we need to find the coefficient of x before x to the power 5. So how we can do, we know that the coefficient from Pascal triangle gives us 35. Next goes term x squared to the power 7 minus, so we determined 3, it means 7 minus 3. So we've got x squared, we just check it in case 7 minus 3 is going to be 4, okay? And we still times 3 cubed, over r, so in this case x to the power of r is 3, so that's why over x cubed. And indeed, if you simplify the powers for x, you'll get x to the 8 minus over x to the cube. It means that you'll get x to the power of 5. So, but the coefficient before is actually these parts. I just highlight them. That's 35 and that's 3 cubed. So in total, we multiply them, and that's how we can get coefficients. So 35 times 3 cube. In other words, the coefficient is going to be 35 times 27. And that's our coefficient. So 27 times 35 is going to be 945. 945. But we also check that correctness for x power. It's definitely power 5. Okay, so that's how it works, and I hope you understand. And that's going to be the single term. I mean, there won't be any x to the power 5, I'm pretty sure. So that was actually explanation, and I hope you understand how it works. So the final result is 945. This is positive coefficient before the x5 terms. Okay, well done. I think that was cool. And don't forget to check the Zillion's A-level class. So right now he has Pure 2, that's fractional binomials. But I hope with the time other visitors and viewers view this video and watch it. He and me actually will have pretty lots of materials to practice for exam style questions and for explanation as well. So don't forget to subscribe if you're new here. That was Daniel Dallas, and peace out.